Hi, and welcome to this talk about challenges for explainable machine learning in production, done by a team at SNT University of Luxembourg in relation with an industrial partner in the fintech industry. I'm Veiber. I'm a research specialist at SNT University of Luxembourg. So machine learning right now is increasingly used in practice in industries. Some of the different tasks involved are automation of administrative tasks, which is mainly done in a variety of industry, of credit scoring, more for the banking industries. Recommender systems that you can see here. I have an example which is taken from Amazon. You have automated vehicles. There have been a lot of talk about this. And there is chatbot also, which is being increasingly used by many companies. But the issue with those algorithms is that they are black box. The inner working of the model to make this decision given one input to the output is not interpretable to the users. So basically there is a trade-off between the high accuracy which is reached by machine learning and its interpretability. The thing that you can actually see is that the more accurate model gets, the less explainable it is. For instance, here on the graph, you can see that the accuracy for neural network is very high. It has a high performance, but it's actually not at all explainable and very black box. There are several motivations behind explainability and how to use it in machine learning. The first is legal. For instance, in Europe, you have GDPR when you have the right for explanation. So anyone can actually ask for an explanation if a model has made its decision based on the data. You have also practical reasons. First, if you don't know how the model made its decision, then you will ask an analyst to come up with why did it make its decision. Several analysts will have different opinion and different explanation with that. So you will end up with a plurality of explanation. There is also users' distrust. So if someone doesn't really understand what the model is doing, this person may be reluctant to use it. There is, of course, the ethical perspective. If you use your model for sensitive tasks, how can you ensure that it is ethical? You need to ensure that. And prudential, obviously, if you make a decision which ends up being wrong and someone asks you why you made the decision, you made the decision based on a model, but you cannot explain why the model gave you that output. So obviously, this can be quite tricky. So here, I explain more in terms of GDPR. So as you can see, this is from Goodman and Flexman, a paper which was in 2016. So they say that there is a right to explanation. So if a user can actually ask for an explanation for an algorithmic decision that was made about them. So you need to understand the logic involved, because if someone asks you with GDPR, you need to be able to tell them. And there is also the fact that in complex tasks, as I said, with the user distrust, industrial, we favor transparent and interpretable models, even if the accuracy is lower. You actually have such an example whereby you have a critical task at end, you use a model, you cannot understand why the model used this decision. Most business people will end up using the model which has a lower accuracy, but is highly interpretable. So here I explain more about our industrial partner. So our industrial partner is in the fintech sector and is mainly interested in explanation of the automated decision making system. So here, what you do have is a highly regulated environment because it is governed by GDPR in Europe. Our industrial partners wanted to address different audiences, whether it was the clients, financial analysts, regulators, or managers. And those people actually don't need different type of explanation. If you put them with the same explanation, then this wouldn't work. They need to derive different information from it. So there is also the fact that they needed to add explainability to models that they didn't want to change. So they wanted to stick with their pre-existing models. In this case, it was random forest. So some argue that actually random forest, because it is based on decision trees, is actually interpretable. Well, a decision tree is interpretable, but as it increases exponentially, it becomes non-interpretable, because imagine you have more and more trees, and how can one person actually get a meaningful explanation when you have 1,000 trees? You need to ensure security and privacy, especially when you're in the fintech sector. So now we'll talk more about explainability. So there's several types of definition. Most of them are conflicting actually. But here in our paper, we refer to explainability as interpretability actually. We use those notions interchangeably. So for us, explainability will help to respond to the opacity of a model, but it will also maintain the learning performance. So it will give the machine learning models the ability to explain and present their own behavior in a meaningful way to humans. There are different types of explanation. The first difference is between global and local, which will refer to the granularity of the explanation. So basically, when you are at a global level, you look more into the overall model, but if you're into the local level, you will look at one prediction. There is also the difference between inherent and post hoc model. So the inherent model incorporates interpretability at the core of the model structure. So it will be part of the model. Post hoc actually requires the model to have been run, and then you add another framework on it to generate the explanation from the initial model. So basically, if you have local inherent model, you will have a model which is already interpretable for the specific prediction. You will not need to generate any explainability framework. If you have inherent at a global level, then the model is actually readily interpretable on the overall perspective. So for instance, it could be a decision tree, because the decision tree, you can see the overall inner working of a model. For the post hoc, as I said, you will need another explainability framework. So you will have an initial model, machine learning model, and then you will need to add explainability framework. If you do it at the local level, then it will be to explain one specific prediction. And if you do it at the global level, you will have a global overall understanding of the model using the explanation. But these different types come actually with different accuracy trade-off. So inherently explainable models will offer higher accurate explanations, but it will lower the performance. If you use post hoc explainability, it is limited in the explanation because obviously it's not from the first model in itself, but it will keep the initial model performance. So for instance, if you use a neural network, you will not lose this high accuracy performance that you get from the neural network, but your explanation will be a little bit constrained. If you use global explanation, then you increase model transparency. And basically what happens in operation is that you increase the trust in the model itself. But if you uncover what happens for a specific input to a specific output at a prediction level, a single prediction, you actually increase trust in the prediction. So what does this mean for practitioners? So you can see the table below, so it's the same as in the previous slide. If you go for inherent explainability, if you look at the local, then you need to find a model which is already interpretable for a specific decision. This could be, for instance, a decision tree again, because for a specific set of variables, then you can follow the tree and you will get the explanation for the specific examples. If you want at the global level, so the overall model explanation, this can also be a linear regression, because there you will have, given each variable, you will have a specific factors which will tell you how this variable will impact the prediction in overall. If you use a post hoc explanation, then what will happen is that you will need to choose a framework to be applied to the machine learning models. So basically, if you use it at a local level, this will explain again a specific instance. For instance, this can be a sensitive analysis. At a global level, then this will explain the overall model again. So in industrial deployment, you will need to consider that the post hoc framework will need to adapt to the initial machine learning model. So there are some frameworks which are actually model dependent. So what happened there? It means that, for instance, some explainability models can only be applied to neural networks. What happened then if you use random forest? This is something that you will need to keep in mind. And also, there are post hoc frameworks which will generate both local and global explanations. So this is great actually for practitioners, because with only one framework, you are able to actually generate local and global explanations. There are also different formats of explanations. The most famous will be a visualization-based framework, which is, again, as I said, the more frequent. So this will produce a graphical representation of the of the predictions. Here below, you can see an experiment from us using the Right for the Right Reason framework from Rosenthal 2017. So basically, if you have a visualization, it's very intuitive for users because when you see an image, you can actually get what's happening. Well, here it's a little bit messy, but we will come back to that later. You also have text-based framework. So here, basically, you will have a textual explanation of your decisions. Here you can see an example from Park and All 2018. They tell you why it is happening using text. Text and visualization are actually the best way to arrive to this explainability, rather than if you get mathematical cues. But the issue with visualization-based framework, as I mentioned a little bit earlier, is that those frameworks are actually rarely validated through user study. They are applied to a specific task in their design process, and the visualization is optimized for the specific task, for the specific data. If you apply it to another task using data which are less optimal, then it can be as non-interpretable as the initial model. So now we'll talk about the challenges and recommendations. As I said, and this is the main topic of our papers, there are a lot of challenges to industrial application of explainable machine learning. We've seen that with our industrial partners, and we've seen medley the issues about data quality, task and model dependency, and security. When I'm talking about data quality, explainability frameworks actually mostly focus on computer vision tasks and natural language processing tasks. The quality of tabular data is not actually addressed in most of the best framework. There is the issue of missing values, no clear clusters, as you can actually see in the image that I put again here. When you see this, it actually kind of looks like a mess. You need to focus a little bit to understand what's happening in here. What it means is that the explainability of this visualization is reduced. The fact is that when you have an explainability framework, it will take on data sets, for instance, the iris data sets that are optimal. There are no missing value. The clusters are very clear cut. But here you actually have a messy data set, the kind of data set that you actually have in operation. The recommendation that we actually give to practitioners and here as well to researchers is that there should be more consideration to industrial needs during the framework design. We should consider the fact that not all data are perfect and that we should be able to derive information even if the data is a complete mess. There is also the fact that we need systematic user validation of those interpretability framework given different data format. So it's not actually enough to have a user validation given images, but you should also this user validation given a natural language data set as well as tabular data set. Right now, there is no clear systematic validation of each framework. You then have the model and task dependency. So as I said already, model dependency is the fact that some frameworks are actually designed specifically for model type. So for instance, specifically for neural networks, specifically for SVM. This is resolved by model agnostic approach, for instance, the line method, and this can also be resolved by surrogate models. The issue with surrogate models is that basically you will have models which will be applied to the initial model, and this model is supposed to be more explainable, maybe less accurate. It will provide explanations to the overall model, but only if the model and the surrogate models output the same prediction. So if they disagree in the output of one prediction, then you won't have an explanation for this prediction. So in terms of task dependency, there is the need that we've seen through our industrial partners that you need different types of explanations for different audience. You cannot give the same explanation to your client that you will give to your financial analyst that you will give to your regulators. This is a completely different need. And there is also an insufficient consideration of the disparate task. There is this fact that you don't actually have a framework which is one solution for all. So the first thing that I would recommend to practitioners is to clearly define the needs of explanation before undertaking any task. So before you even say, okay, let's apply this framework, you should say to whom you want to give this explanation. And also you should decide whether it should be local, whether it should be global, what you want as the end product. given this explanation. There should also, again, be a systematic review of the relevant interpretability frameworks. This is to be done at the industry level, because before you undertake a task and before you apply the framework, one thing that would be good is to take a subset, a smaller task, and to do a review of the different frameworks that could be applied to the task. So then you actually know in which direction you're going. Finally, there is the issue of security. So the first issue that comes with security is actually robustness. If someone has access to the model reasoning, knows how the model behaves, then someone could apply an adversarial behavior to alter the models. There is also a new research which is cited in our paper. This research actually said that if you provide explanation, then someone could actually retrieve or recover part of the initial data set. And this is especially worrying. This should be further researched. So our recommendation would be to simulate adversarial behavior and see if you observe any alteration in the model behavior. Regarding the second challenges, I would say that you should give on to the exercise of recovering part of the data set given explanations. So you give explanations to maybe someone who has a small knowledge of the data set but hasn't worked on the explainability framework, and you say, try if you can recover the data set from that. Finally, to conclude, so data are crucial for operational decision making because you can derive information, which is a competitive advantage. There is this big trade-off between explainability and accuracy. And the issue is that most of the accurate machine learning models are black box. And explainable machine learning can make the model interpretable to users. It can help with these opaque models. Nevertheless, there exist challenges toward explainable machine learning implementation, which is data quality, task and model dependency, as well as security. Overcoming those challenges can be very complex, and systematic user review of interpretability frameworks and of operational use cases will definitely be key to ease those challenges in the future when explainable machine learnings become more and more needed. So thank you for listening. And I would like also to thank everyone who contributed to the paper. You can join me using this email address if you have any questions. Thank you.